Welcome back again to today's class. In the view of the forthcoming exam, physics practicals, then I was able to come up with this analysis on the board and this diagram arrangement. Now, you may be asked to do something like this or otherwise, but whichever way, I want you to understand the concept behind the apparatus we are asked to provide, in case they bring something similar to this. But if you understand the concept, you'll be able to understand what they are going to do in your exams. Now, I want you to watch this video to the end and make sure you subscribe to this channel for more updates. With no further ado, let's get right into the video. Now, looking at the arrangement we have on the board, this is a meter rule, ranges from 0 to 100, okay? Now, I'm going to read out this procedure and I want you to explain this concept. So, let's go. I fix the 100 gram mass marked N at P, the 80 cm mark of the uniform meter rule using an adhesive. That means you're going to fix the 100 gram mass labeled N at this 80 cm mark, okay, all right, with an adhesive. Using a sellotape is an adhesive. Just put it here and fix it. All right, I suspend another 100 gram mass marked Q at A distance V equals 10 cm from the 0 cm mark of the meter rule. It simply means that you're going to use what? You're going to hang another mass called Q, but it's 100 gram mass called Q. You're going to hang it at a distance A, and the distance, which is V, equals what? 10 centimeters. That means from here to here, V is going to be 10 centimeters. That simply means you're going to hang this 100 gram mass at a distance of what? 10 centimeters from 0. Do you understand? Okay. I says balance the whole arrangement and measure the distance U of K. Where is U of K? Look at it. See my knife edge. Okay. When I balance it after hanging the mass of 100 gram at 10 cm mark, I'm going to do what? Balance the ruler on the knife edge and measure the distance from where the meter rule is balanced on the knife edge to the starting point, which is what? 0. That becomes my U. Okay. Now, in this concept, we are not asked to measure the CG, but you should know that you may be asked to measure the CG of a meter rule. That's the first thing I'm going to do before I start with this my procedure. Okay. All right. Now, we are going to repeat this procedure for 5 other values of V equals 15 cm, 20, 25, 30, and 35 centimeters. It means that we are going to keep this at 10 cm. We adjust the position of this meter rule on the knife edge, okay, to get our U, which is the distance from here to here. When we are done with that, we repeat it again by shifting this to what? From 10 to 15. So it means in this experiment, this mass hung at 80 cm mark, which is our unknown, is going to remain constant throughout this procedure. Do we understand? So the first thing I'm going to do, even though I told you that I use 2001 past question to prepare this, it did not ask us to measure CG, but you need to know how to measure CG, which is center of gravity. Now, for us to measure the CG, is simply by placing this meter rule on this knife edge and see where it's going to balance horizontally. That is just your CG. You just have to record the points. Is that okay? So let's go. You can go. Now look at it. We have to place it this way. Look at it now. If it takes time to fall on either side, it is balanced, because you have to avoid air resistance by closing the windows and offing the fan. Can I see it now? All right, so let's measure the CG. My CG is at, you look from this end, you look from here, look at the point of the CG, of the knife edge. If it takes time to fall on each side, that is your CG, okay? Now this is a 49.40. That is my CG, 49.40. Okay, you just have to record it. 100 gram mass, label N, fixed at 80. This is going to remain fixed at this position throughout the procedure. Now look at my another 100 gram mass. I'm going to first place it at 10 cm. So let's proceed. Remember, I'm going to place it at 10 cm. 10 cm mark. This meter rule has 2 calibrations from this side and this side. So because I'm using this one, I'm going to read from here. This is 10, okay? Now let's go. We're going to balance it here. You keep adjusting this until it is balanced horizontally, right? Now, because of wind or draft, you might have difficulty in balancing it. So in your school, you should just make sure you off the fan and close the windows, because any little air can make you to have incorrect balance point. But nevertheless, you have to try as much as you can to avert that. That is part of precaution. Now let's go. That is why I say if it takes time to fall on either side, it is what? Balance. Look at it. You see how I'm adjusting it now? Can you see it now? Alright, look at it now. If it takes time to fall on this, you can see that it is balanced now. You just have to record what you have. This has balanced at 46.80 when V is 10 cm. Okay? Now let's record what you have. 46. Now repeat the procedure by adjusting this and keeping this value at 15 cm, then keep adjusting it again to balance it horizontally. That means in this experiment, the CG is not kept constant. What is kept constant is just the 100 gram mass label N. We have 48.40 when V is kept at 15 centimeters. So we adjust again to keep V at 20 cm mark. Okay, so let's balance it. Now I have 49.80. So this is what I have when V is kept as what? 20 centimeters. So record it. Okay, I'm going to complete this procedure with this method and get the values of V and then plot the graph. So let's go. All right, having performed the task, see my values or table of value that I have. Now I have this is CG. CG is your center of gravity, so you have to learn how to measure it. This is I got mine as 49.40. Okay, now this is my serial number, this is my V, and this is my U. Remember, it is measured in centimeters. Don't forget to put your unit. So I'm going to teach you how to plot the graph. So the question says that we should plot a graph of U against what? V. That is I plot a graph of U against V. Okay, now this will be on the vertical, why this will be on the horizontal. So people will ask, why didn't I subtract from the CG? No, from this particular question they didn't say we should subtract. Okay, they said we should measure U, which is the distance from where the knife edge is placed to the 0 point. So that is what we measure to have this. I hope that is clear. All right, so we are going to also equally find the slope and also intercept. Okay, so let's proceed. Now let's proceed by sketching our line. This is vertical. Okay, so what we're going to do now, let's put our values. This is V measured in centimeters, while this is U measured in centimeters, right? The question says plot a graph of this. So let me write my title. A graph of U against V, right? So look at what we have. All the value ranges from 46 to 54. So I'm going to look for a good scale that will fit in what I have. Don't start with 46, so because if you start with 46 for 2 cm, that means your next value is going to be what? 92. So but this is not what you are requested to do. So I'm going to start from here. I'm going to use 2 cm to 10 units so that at interval is going to be increasing by 2 cm on U axis. So this is what? Sorry. So that on interval is going to be increasing by 10 cm on U axis. So this is 10. This is going to be 20. this is 30, this is 40, 50, 60 to the end, right? All right, on this axis, from what I have from 10 to 35. That means I'm going to increase it in order of what? 5. So I have 5, 10, 20, 25, 30. Sorry, this is 15. This 20, 25, and this 30, and this 35. Okay, sorry for that. So let's proceed. So I'll go this way. Remember to write my scale. I'll say scale 2 cm to 10 units on u-axis. Okay, then come again, 2 cm to 5 units on v-axis. From here to here is 10, and I have 10 boxes. Now what do? I want to know what one line stands for. I'm going to say 10 divided by 10 is going to give me 1. Okay, so this increases by what? By 1. On this other side it has what? 5. So 5 divided by 10 is going to give me 0.5. So each line is what? 0.5, 1, 1.5, 2. So let's proceed. Now the first one I have here, I have 46.80 at against what? 10. So what I'm going to do, I'm going to approximate this to give me what? 47. Okay. Now this is that's what I want. This 40, 41, 42, 43, 44, 45, 46, 47. Mind you, I'm using black pen for visibility sake, okay? When you're plotting, you're supposed to use pencil, very sharp pencil, okay? As against 10, let me look for the meeting point. Look at 10 on the v-axis. What's the meeting point? They met here. Now in this one, I have to approximate because from the scale I have, there is no point that will work. So I need to approximate to a whole number to be able to use this. I hope that is clear. All right, the second one is when u is at 48. Now this is 48.40, but because this 4 is not up to 5, I'm just going to work with 48. Okay. Now when this is at 48, my v is 15. So on 15, I go this way. You can see it now. So with this procedure, I'll plot the whole of the graph. Now the next one is 49.80. Okay, I approximate to have what? 50 at against what? 20. So let's go. This 20. I'm going to complete the graph so you can find the slope. Now look at what I have. I have plotted on my readings. So you can just circle it to be on the safe side. Okay, now let me go. I'm going to join it to find my slope. Remember, not all the points will enter the line, okay? But you try as much as you can to see if it's possible. But if it's not, remember you should take note of line of best fit. So I have 1, 2, 3, 4. It can go out of 6. So just join your line. Join your point, sorry. I have something like this. Okay, so the next thing is to find my slope. I'm going to find my slope. By choosing a very good triangle. Okay, now so this is what I have. I'm going to say this is change in V versus change in what? In U, right? Because this V is for horizontal, while U is for vertical. So you can decide to trace it down. You can decide to trace it down. I've chosen my triangle. I have to extend. Now this is V1. Why this is what? V2. Why this is what? U1 and what? U2. So let me find my slope. So my slope is equals to change in U over change in V, right? This is centimeter over centimeter, right? Okay, now this is equals to U2 minus U1 all over V2 minus V1. So let's go. What's my U2? I'll come here. This is 50. This is 54, right? Now this is 54 minus my U1 is 45. I will say minus 45 divided by. Now this is V2 is 30, 31, 32, 33. This is 33.5. So this is 33.5 minus. This is 33.5 minus 4. So let me work it out. I'm going to say this is 50 minus 45 to give me 9 divided by 33.5 minus 4. I'm going to have 29.5, okay? Now by the time I divide, 9 divided by 29.5 is going to give me 0.305, okay? So that means my slope is equal to 0.3. Want to change it to 2 decimal places, I'm going to have 0.31, right? That is my slope. Remember, the slope has no SI unit because centimeter cancels what? Centimeter. Okay? Now, the next question I'm going to find is intercept. Intercept C on the vertical axis. From what I have, look at it. This is 40, 41, 42, 43, 44. Where this line cut the vertical axis, it cut it at 44. So that is my intercept, okay? So I have to record that my intercept C equals to 44 centimeter. Remember, I have to make a mark and write C for them. Let them know that they have measured the intercept, right? Now this is 44 centimeters. I hope that is clear. You may be asked to evaluate K, which is K1 equals 1 minus 2x over x, then bracket 100, okay? Now I'm going to say this is 1 minus 2 times, my x is my slope, and I got it at 0.31 over 0.31, right? Then bracket 100. Do you understand? So what I'm going to do is to work it out. I will say 1 minus 0.31 times 2 is going to give me 0.62 divided by 0.31, then bracket what? 100. Let me work it out. Now this is 1 minus 0.62 equals this, okay? Then divided by 0.31 as my slope, all right? Multiply by 100. Now this gives me 122.58, okay? Now let me evaluate these two. This is going to give me 2 times, my slope is 44, sorry, my intercept is 44, divided by what? Slope, which is 0.31, then minus 160, okay? So let me go 2 times 44 equals to 88, divided by 0.31 is equals to 283.87, then minus 160. I will have 123.87. I have 123.87 centimeters. Is that clear? Now this is part of the thing they might ask you to evaluate if you perform this type of what? Experiment. Now for the precautions, you must personalize it. I avoided draft by offing the fan and closing the windows because of air resistance, okay? Now, I ensure that the mass does not rest on the table. I personalize it, okay? Because you're the one that performed this experiment. Number 3, I avoided error due to parallax when reading the meter rule. This is some of the precautions you must note while performing this experiment. If this video was able to help someone out there, please don't forget to subscribe to this channel and turn on notifications to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for this same forthcoming exam can see it and learn from there. See you next time in my next one. Bye for now.